Kirchhoffs Voltage Law. Let us try to understand the term, which is very important in case of all the engineering aspects. So the Kirchhoff Voltage Law is also called as KVL. According to this, the algebraic sum of all the branch voltages around any closed loop, this is important, around any closed loop in the network is zero at all instant of time. It means that if we are considering a closed loop, this is again once again I am repeating, we should be considering the closed loop. So if we are having any closed loop and we take algebraic sum of all the voltages, then it should be zero. Let us try to understand this with some example. Like let us consider we have one circuit. Here we have a voltage source, let us say Vs. It is having polarity like this, positive, negative, and let us connect some element. Now these elements can be anything. uh, let us say Z1, this is Z2, and likewise we consider the next one, that is Z3, and circuit is completed, means the loop is now closed. It means if the current is flowing, so it will get the complete path to flow through. That's why it is said that the loop is now completed. So now with this sign convention, let us go for the this KVL. So here before we go for analysis, we should be knowing what are the different sign conventions we have to consider. So that's why sign conventions. So it is said that if you are moving in the loop and if you are moving from negative to positive side, it should be considered as a rise of the voltage. Like let us consider, first of all let us consider the current direction. You can consider any current direction, but as we know the current will start from positive end and go to the negative. So in this way the current should flow in the circuit, right? It will start here from Z1, Z2, Z3 and then go back to negative end. So during this course of journey we have to consider the direction. So if we have decided the direction, now another rule is that if you are moving from minus to plus, so it is considered as rise of the voltage, and that's why it is considered to be positive. Likewise, if you are moving from positive to negative, then it is considered as drop, and that's why it is considered to be negative voltage, right? So it means that in this case, if we have to move in the circuit as per the direction shown by this arrow, then here we can see if we are moving uh, like this from here to here, so minus to plus, that's why the sign of Vs will be positive here, right? Okay, in this way if we consider the voltage which is generated here is V1, voltage generated here is V2, and voltage generated here is V3. So now as we are moving in this direction, and here let us consider as we know the current is flowing in this direction, so voltage generated will be like this. Let me just give the notations first. This is the thing, and now with this, if we are moving in this direction, so V1 will be means while moving through this Z1 we have to move from positive to negative end. That's why V1 will be considered to be minus, right? In the same manner here also, in the same direction if we are moving from positive to negative, that's why V2 will also be minus. We have to move from positive into negative here, that's why V3 will also be minus, right? And ultimately after considering this sign conventions, we should be applying the Kirchhoff voltage law, and it said that sum of all the branch voltages around the loop will also be zero. Means if we take the sum of all this voltages, it should come to be zero. So I should be simply adding them, so it should be zero. That is what the KVL says. Further, what we can write from this is Vs. If I take all this on the right hand side, so we will have V1 plus V2 plus V3. It can also be stated that the total voltage given by the supply Vs is divided into the voltage V1, V2 and V3. That is what the meaning is. Let us try to understand the same concept in brief using this example. So here what we have done, we have taken two voltage sources and the three resistors, right? And the voltage sources are having the polarity like this. First thing what we have to do is we have to consider a loop through which the current is flowing, and we have to consider the voltages generated. Let us consider due to this connection the current is flowing in this loop like this. This is our consideration. Let us consider this current to be I, which is flowing through this. Another thing is that let us consider the voltages which are generated due to this connection. Let us say the voltage generated here is V1. It is having polarity like this. We have flexibility to consider the polarity as per our requirement. So let us consider V2 will be generated in this resistor. It is having polarity like this, and V3 will be generated here. V3, it will be having polarity positive and negative here. So that is the voltage V3 generated in this resistor, which is resistor 15 ohm. Okay. Now with this convention, let us apply KVL. So applying KVL in this circuit, what we have now, we should remember the sign conventions. So here we know if we are moving from negative to positive, we should consider it to be positive. If we are moving from positive to negative, then it's a drop of voltage, so it is negative. So here let us consider this point A, right? So from this point we'll start circulating, means we'll circulate like this. Okay. So during this journey, if we are circulating, so like we are moving from minus to plus here, so that's why it should be taken to be 5 plus. Okay, then we come here, then here we are moving from positive to negative, so that's why the voltage V1 should be considered to be negative. Okay, remember this. Again, in the course of journey, here then comes V2, but we have to move from positive to negative, that's why again it is minus V2. Again here when we come, we have to move from positive to negative, so that's why it should be again considered to be negative 2 volt. Then again here we are moving in the same direction, so positive to negative, so that's why it's minus V3, and here it completes the loop, and that's why again the algebraic sum of all the branch voltages in the closed loop is 0, that's why this is equal to 0. Okay, so now this further we can solve, like 5 minus 2, it will become 3, right? And all these negative voltages, if we take on the right hand side, it will become V1 plus V2 plus V3. So it means that the voltages V1, V2 plus V3 will be equal to 3 volt. Now if we are interested in solving further, means if we are interested in getting the values of V1, V2 and V3 and I, then we can go further, like by considering the Ohm's law. We know Ohm's law, which is nothing but V is equal to I into R. So what we can write, V1 is equal to I into this. V1 is nothing but the current flowing through this multiplied by 5. So that's why V1 is equal to I multiplied by 5. So it's a 5I, right? In the same manner, V2 is equal to I into 10. So that's why it's 10I. In the same manner, V3 will become I into 15. So it's 15I, right? So now what I will do, I will put the value of V1 is equal to 5I, V2 is equal to 10I and V3 is equal to 15I in this equation. So if I put these all values, what I will be getting, I will be getting the equation like 3 is equal to 5I plus 10I plus 15I. Taking this further, this becomes equal to 30I, right? Now from this equation, I think all of us can get the value of I. So value of I, let me write, okay. So value of I will become now 3 divided by 30. So it comes to be 0.1 ampere. So value of the current which is flowing through this loop is 0.1 ampere. Now if somebody want, he or she can get the values of V1, V2 and V3. So we know V1 is equal to 5 into I. So that's why V1 will become 0.1 into 5. So it is nothing but 0.5 volt. Likewise, V2 is nothing but a 10 into 0.1. So it is nothing but 1 volt. And this is V3. So V3 will become 15 into I. So 15 into this 0.1, it will become 1.5. Now here you can see, if you add this all three voltages, 1.5 plus 1, it is 2.5, plus 0.5, it is 3. So the same thing we have now. V1 plus V2 plus V3, if you put this all values, you can check, it is coming to be 3. So this is how we can use the KVL for finding out the current and voltages flowing in a closed loop.